physics. Fields, lesson 1. Okay. Well, if a charge on a particle is doubled, then what happens to the force? Anyone get this one? If the charge is doubled, what happens to the force? Increase how much? Doubled also, yeah. Yeah. So, you have F equals QE. So if Q becomes, 2Q, then that means F will become 2F. So it doubles as well. That's okay, yeah? Alright, the next one. A 1 microgram particle of 1 millicoulomb is attracted towards the center of an electric field. The field causes the particle to accelerate from rest over a distance of 1 centimeter in 1 second. How strong is the electric field? Okay, so you have your field here. And you have your particle. You have your particle here. And it has a UVATS that it starts at rest, accelerates a distance of 1 centimeter over a time of 1 second. Do we know its mass? We do. It's 1 microgram and 1 millicoulomb. What's what? 1 millicoulomb is the charge and 1 microgram is the mass. Yeah. So I ask you for the E. The E is F over Q. Now, oh, by the way, I should change this into this is 10 minus 9 kilograms, and this is 10 minus 3 coulombs. Okay. So when you look at this formula, what do you know and what do you not know? So what do you know?
Q.
We know
Q.
Q. Do we know F?
No.
We don't know F. How can we calculate F?
MA.
We can use Newton. F equals MA. So now we have MAQ. Now what do we know now? Q and the M. Do we know the A? Well, we could know it. right? Because we could say S equals UT plus a half AT squared, but the U is 0. So S equals a half AT squared. So that means A is 2S over T squared, which is 0.02 over 1, which is 0.02. Now we know the A. So it should be 10 to the minus 9 times 0.02 all over 10 to the minus 3. Is that equals? $20 nano newtons per coulomb. Not so difficult now? It's okay? Was my trick. Next question? Is that yes or no? Amanda, you look confused. No? Okay. Next now, 2 milligram dust particle falls from one copper plate to a lower copper plate.
Sorry, but nanogram is any is using 10 to the minus.
This one? This. Oh, this one. It is 10 to the minus 6. Correct. But that's 10 to the minus 6 grams. And we use kilograms. So 10 to the minus 6 grams is 10 to the minus 6, 0.001 kilogram. Yeah, which is 10 to the minus 9 kilograms. Yeah. Okay, number 3. A 2 milligram dust particle falls from one copper plate to a lower copper plate, a distance of 10 centimeters, and it took 10 seconds to do so. Okay, so what? I'll draw that now. So this distance here is 10 centimeters, and the particle's charge is minus 200 E, and its mass is 2 milligrams. 2 milligrams. So that's 2 milli. So 2 times 10 to the minus 6 kilograms. And it took 10 seconds to fall. Is 10 seconds too big or too small?
Too big.
Too big. So what must be happening, there's a force going up from the electric field and a force going down, which is its weight. And I would say that the F is nearly as big as the W, but I still think the F is smaller than the W. But because this time is so big, it makes me think that they're nearly the same. Okay, first business, get the A. UVATS 0, don't know, 10, 10. S equals UT plus a half AT squared. S is 0. S is a half AT squared. So that means 2S over T squared is the A. So that means A is 0.20 over 100, which is 0.002 meters per second squared. Yeah, so far okay? Now Newton says that the force should equal MA, so that should be 2 times 10 to the minus 6 times 0.002, which will be 4 times 10 to the minus 9 newtons. But what is the total force here? What is the total force? Well, the total force will be W minus F. This is how much force is going down. This is the total. That will be 2 times 10 to the minus 6 times 9.81 minus Q. And I don't need the minus here again. So 200 E, because we're using the formula F equals QE. So now I can get the E. It will be 4 times 10 to the minus 9 minus 2 times 9.81 times 10 to the minus 6 all over minus 200E. So that will be 2 times 9.81 times 10 to the minus 6 minus 4 times 10 to the minus 9 all over 200E. Okay, let's have a look. Here?
No, the last.
Here?
Minus 200 E, right?
Yeah, but I flipped the numerator around. See, it's backwards now.
Oh.
In other words, I multiply the top and the bottom by minus 1. Yeah. Right, I got a big number. 6.12 times 10 to the 11 newtons per coulomb. 6 is mega, 9 is giga, 12 is tera. (612 giga newtons per coulomb). No reason, just make it look pretty. Yeah. Can you see?
The force equals MA.
Yep.
2 multiplied 10 to the minus 6
The mass.
is equal to 0.002.
Sorry, that's not equals. That's ugly. That's multiply there. Because this is the M and this is the A. Next one. In a moment. Yep.
The E 200E is like 200 multiple 1.6
All explained yesterday. Yeah. The E is the electron charge. Yeah. Okay. One electron orbits one proton, and there's the electric field strength. What is the periodic time? Good question. So what you have here is electron orbits proton, and there's a force here, of course. The electric field strength is 1.4 times 10 to the minus 10 newtons per coulomb, and the distance away is 10 to the minus 10 meters. Oh, sorry, you can't see that up there. Yeah, tastes bad. Too warm. Alright. Continue? Yep. Right. What's the formula for the force? That's one formula? Yeah. Yeah. So, we could use this one because we know the Q and we know the E, don't we? So let's use this one first. F equals E times 1.4 times 10 to the minus 10. So F equals 2.24 times 10 to the minus 29 newtons. Yeah. Now, there is another formula for F though, because it's moving in a circle. Do you remember? You also can say F equals m omega squared or F equals mv squared over or. I'm going to use this one now. I have m omega squared or equals 2.24 times 10 to the minus 29. So omega squared equals 2.24 times 10 to the minus 29 all over the mass of an electron times 10 to the minus 10, which is the radius. And then omega will be the square root of this. So omega is 496,221 radians a second. But T equals 2 pi over omega. So this is 1.27 times 10 to the minus 5 seconds. Or if you want, the time is 12.7 microseconds. That's the answer. Do you understand that here this is mass of electron, which we know?
How is the W and the T
This formula from circular motion. Do you recall? Are you sure?
I have to refresh.
Yes, good idea. No good? It's okay? Or I know. We're using stuff in semester 1 and semester 2. Yes. Most students don't like this chapter. Like you, and like others maybe. But still, we must do it. Okay. I can close this?